So moving into section 5.2, what's nice about this is you just finished deriving with natural log, and so we immediately get to turn around and integrate rather than in previous chapters when we had to wait multiple chapters until we learned kind of the opposite direction. So we have two theorems, and they are basically for the most basic integral that involves natural log, and then for one that involves u substitution. So first of all, if you end up with just 1 over x, and you're asked to integrate it, you get just natural log of x. Now, the reason is the derivative of natural log of one over of x is 1 over x. If there's a number in front of it, so let's say there's a 4 on top. Well, this is still a natural log of x. It just has a 4 as the coefficient. Notation. I want to make a note of notation. When you are integrating and your result is a natural log function, one thing you'll notice about the way your answer is written is they always put a absolute value around what you're taking the natural log of. The reason for this is because natural log can only work with things that are positive. Excuse me. So you putting that notation guarantees that. It's not a huge deal if you forget to put the absolute value, but it is something that you should start to get into that habit, and it will really come into play when we start working with numerical ones that we have to find definite integrals. The more common one is when you are integrating something that is in the form du over u, where u is your denominator, du is your numerator, or you may have an adjustment. So I'm going to make a comment for that. You want to look for adjustment. We know that the derivative of natural log of a function is the derivative over the original, the du over the u. So if we get it in an integration form that's du over u, possibly with an adjustment, it integrates as the natural log. Now this is interesting because this is the only one that you can't do as a power rule. If you think about our power rule, so instead of doing it as du over u, if you try to think of it as like u to the negative 1, here's where this kind of collapses and you can't do this. Power 1 greater than negative 1 is the 0 power over 0. It is the one time that our power rule is ineffective, and that's why we do have to consider it as a natural log integral. So again, you're looking for du over u to just the first power, see if you need to make an adjustment, and that is a natural log integral. So let's practice some basic ones. We're going to break this down into 3 videos: basic ones, special case ones, and definite integral ones. First one's really quick. Excuse me. If you have a number on top, it is just the coefficient, so you end up with 2 natural log of x. No u sub needed, no adjustment needed. The second one, you have this 2x plus 6 in the bottom, so that's going to be your u function. We often call these like rational integrals. The derivative of that is 2, which you don't have in the original integral, so your adjustment is going to divide by 2, so you have a 1/2 adjustment. The form this is in is a du over u form. Again, you don't want to think of it as a power rule because you'll kind of fall apart with dividing by 0. So you get 1/2 the natural log of 2x plus 6. I do want to mention a couple ways to write your answer. Obviously, this is probably the way that you're going to choose just because it is really quick. One thing you may see is they may use log properties on a multiple choice question and write this 1/2 as the power of the 2x plus 6. So you may see it written as the natural log of the square root of 2x plus 6. And I only mention that because if this was a multiple choice question and you get to here and you don't see your answer, I don't want to think you did something wrong. This is just another way to present that exact same answer, just using log properties. Third one, same thing. Your u is what's going on the bottom. The derivative is 2x. You have the x, you don't have the 2, so you're going to divide both sides by 2, giving you a 1/2 adjustment. Again, the form that we're looking for today is this du over u form. If anything else was happening, if it was a u squared in the bottom, if it was a u cubed, any other power, it's just a power rule. This is really just a very special case that works only for this form. So when you integrate, you get 1/2 the natural log of u, which is x squared plus 5. The absolute values are actually kind of unnecessary here because x squared plus 5 is always positive, but you can still put it. You can also use parentheses. You can also take that 1/2 and make it the power of what you're taking the natural log of. A couple more that just look a little different. They're same idea though. So your u again is the bottom. What you're going to notice with these is the bottom is going to be more complicated, higher degree. Derivative is 3x squared plus 1, which is exactly what you have in the numerator. So this is a perfect du over u, no adjustment needed. So it works out to be just the natural log of x cubed plus x. And since you know how to take the derivative of that, which is what we learned last section in this chapter, you could take the derivative and make sure you get what you started with. Really, we're just kind of working in reverse from what we did in 5.1. 5.1 and 5.2 kind of go hand in hand that way. We derive for a day and then we turn around and we integrate for a day. I did want to show you trig 1. These don't show up a lot with trig. If you have something like this, though, you can let u just be tangent because the derivative of tangent is secant squared. Anytime you have tangents and secant squared somewhere in your integral, that's the u substitution that's going to work. Because of the derivative of tangent being secant squared. So this is, again, is a perfect du over u. So we get the natural log of the tangent of x plus c. So those are your most basic natural log integrals. You are looking for this form, which is different than any other power rule that you could have done, hoping that you could either with a quick adjustment or no adjustment at all, get it to be a natural log of u.